October 19th, 2017. A Harvard professor stakes his reputation on 5 words that would haunt him forever. It's probably an alien spacecraft. What did he see that made him risk everything? The Pan-STARRS telescope in Hawaii wasn't looking for visitors. It was tracking asteroids, mapping space debris, doing the routine work that keeps Earth safe. But on that October morning, something appeared in the data that shouldn't exist. An object. Moving fast. Too fast. Rob Warwick, the astronomer who first spotted it, ran the numbers 3 times. The trajectory made no sense. This thing wasn't orbiting the sun like everything else in our solar system. It was passing through, a tourist from somewhere else. They named it Oumuamua. Hawaiian for scout or messenger from the distant past. But messenger from where? And carrying what message? Within days, every major telescope on Earth turned toward the intruder. The data came back strange. All of it strange. Shape, long and thin. 10 times longer than it was wide. Like a cigar, or a needle, or something built to move through space efficiently. No asteroid looks like that. No comet looks like that. But something else does. Here's where it gets dark. As Oumuamua rounded the sun and headed back out toward deep space, it accelerated. Not from gravity, from something else. Comets do this. When they heat up near the sun, ice turns to gas, creating a small rocket effect. Simple physics. Except Oumuamua showed no tail, no gas plume, no outgassing at all. So what pushed it? The scientific community scrambled for explanations. Maybe it's made of solid hydrogen, never observed, theoretically impossible to stay solid. Maybe it's a dust bunny held together by static, but it would have torn apart. Maybe our instruments missed the outgassing, but every telescope watching failed simultaneously. None of it worked. None of it explained the acceleration without the gas. Professor Loeb at Harvard ran different calculations. Calculations that assumed one thing the others refused to consider: artificial origin. If Oumuamua was a light sail, a thin reflective sheet designed to catch stellar radiation, the acceleration made perfect sense. The trajectory made sense. Everything made sense, except the implications. He published the paper. The academic world erupted, not with curiosity, with fury. What happened next reveals something darker than space itself. What we do when reality threatens our comfort. Loeb wasn't a fringe scientist. He was chair of Harvard's astronomy department, former member of the President's Council of Advisors on Science and Technology, the man who helped detect the first exoplanets. His credentials didn't matter. Colleagues called him reckless, attention-seeking, delusional. One astronomer said he was damaging the field. Another claimed he was weaponizing academic freedom for suggesting we study an anomaly with scientific rigor. The criticism wasn't about his data. His calculations were sound. It was about the question itself. In modern astronomy, certain questions are forbidden, not because they're unscientific, but because they're uncomfortable. Think about what this means. We sent telescopes to find exoplanets that might harbor life. We broadcast messages into space announcing our presence. We spend billions searching for biosignatures in distant atmospheres. But when something anomalous flies through our own solar system, exhibiting behavior we cannot explain with natural phenomena, we're not allowed to consider artificial origins? The suppression was systematic, and it was successful. By the time the scientific community finished debating, Oumuamua was gone, moving at 58,900 miles per hour toward the constellation Pegasus. Unreachable, unstudyable. We had one chance. We argued instead. Here's what we know for certain. Oumuamua is the first interstellar object ever detected passing through our solar system. Statistically, there should be more. Many more. But we've only seen 2. Oumuamua and Borisov, which behaved like a normal comet. Why was the first one so strange? Oumuamua tumbled chaotically as it moved, rotating every 7 to 8 hours. Natural objects don't tumble like that without collision damage. But it showed no impact craters, no fragmentation. It reflected light oddly, 10 times more reflective than typical asteroids, almost metallic, and that acceleration, that unexplained, impossible acceleration. Harvard proposed the Galileo Project, a program to systematically search for technological signatures of extraterrestrial civilizations. Private funding. No government oversight. No academic politics. The response from the scientific establishment? Mostly silence. Because here's the truth they won't say out loud. If Oumuamua was artificial, it changes everything. It means someone is out there. It means they're advanced enough for interstellar travel. It means they came close enough to study us. And it means they left without making contact. Why would they do that? Come all this way and say nothing? Unless they already got what they needed. There's a concept in cosmology called the Great Filter. The idea that somewhere between primitive life and interstellar civilization, there's a barrier, a test that almost no one passes. We don't know where that filter is. Behind us? Ahead of us? What if Oumuamua was checking? Think about the timing. It appeared just as humanity reached the threshold of becoming a spacefaring species. SpaceX, Blue Origin, plans for Mars. We're on the edge of something. What if advanced civilizations send probes to watch for this moment, to catalog emerging species, to assess threat levels, or to say goodbye before the inevitable happens? The Fermi paradox asks, where is everybody? If the universe is teeming with life, why the silence? Maybe they're not silent. Maybe they're watching, quietly, from a distance. Maybe Oumuamua was a scout, and maybe the report it sent home wasn't encouraging. In 2019, a scientist at the European Space Agency proposed a mission. Catch up to Oumuamua, launch a probe fast enough to reach it, study it, answer the questions. The mission was deemed technically feasible, but financially impractical. We chose not to know. On long winter nights at observatories around the world, astronomers still search the sky for the next Oumuamua. They've upgraded detection systems, improved tracking protocols. They're ready for the next one, sort of, but they're not ready for what it might confirm. Because if Loeb was right, if Oumuamua was artificial, then the universe isn't just full of planets and stars and cosmic dust. It's full of watchers, and one of them flew through our home, looked around, measured something, and left. What did it measure? What did it find, and why didn't it stay? The object is now beyond Neptune's orbit, moving toward interstellar space at impossible speeds. In a few years, it'll be beyond our detection capability entirely, a mystery disappearing into the darkness. We had months to study it. We spent them arguing about whether we were allowed to ask the question. The universe is full, but no one answers. Maybe because they already did, and we weren't listening. Or maybe they were listening to us, recording everything. The visitor came, the visitor saw, the visitor left. And somewhere out in the black, past Pegasus, past the reaches of human sight, Oumuamua is still flying, still tumbling, still carrying whatever data it collected, back to whoever sent it. In 2026, the Vera Rubin Observatory begins operations. It will detect thousands of interstellar objects. The question is, are you ready for the answers?